Yeah. So as you know, we have started with circles in the last class only. Okay. And we have done some of the theorems. Okay. So I'll give you a quick revision about whatever we have done. We have done some theorems. One of them is this, that is, the angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. That is, if I draw this kind of two arcs, that means this angle will be double of this angle. The angle subtended at the center will always be double of the angle which the same arc will subtend at any point on the circle. Fine, this theorem we have done. We have also proved it. We have also done this. We have also done this proof that if you have this as the arc, and if any angle subtended by this arc on the circle, all the angles will be equal. Okay, like this. All these angles will be equal. These two theorems we have done. Now you have further theorems, so let's do them. Just a moment. The next theorem is the angle in a semicircle is always a right angle triangle. Is always a right angle. Yeah. So how we can prove that it is a right angle? See, if I draw any circle like this, if I draw a circle over here like this, and if suppose I'm drawing a semicircle to it, that means I'm drawing a diameter to it. Okay. We know that a diameter passes through the center of the circle, and if I draw any of the line over here, we need to prove that this angle is what? 90 degree. This angle is how much? 90 degree. That's what we need to prove. Okay, what is given in this? Given part is AC is diameter of the circle. AC is what? Diameter of circle. Okay, and we need to prove. To prove is angle ABC is 90 degree. Okay, we need to prove. Yeah. Now we need to prove that angle ABC over here is 90 degree. We need to prove this, right? Now, if I say we know that angle subtended at the center is always double of the angle which it will subtend at any other point on the circle, right? So what we can say, angle AOC will be what? Twice of angle ABC, yes or no? The same theorem. That what is that? Angle subtended at the center of circle, at the center of circle by an arc is double than its substance at any point, at any point on the circle, right? We have done this theorem, but we know that angle AOC is how much? Angle AOC is how much? It's a straight line, so it will be 180 degree. Is twice of angle ABC. So what do you get? Angle ABC equals 90 degree. Understood this? Why angle in a semicircle is 90 degree? Because this angle will be double of this angle. If this is 180, then this will be 90. Clear? Fine. Now the next question. Sorry, the next theorem if we have any. Now the next theorem you have is this one. The opposite angles of a cyclic quadrilateral are supplementary. What? The opposite angles of a cyclic quadrilateral. What is cyclic quadrilateral? I hope you are aware. Means if I draw a circle and if I draw a quadrilateral inside, any type of quadrilateral which touches all the vertices of the circle, where all the vertices of a quadrilateral are touching the circumference of the circle, then what we will say that the quadrilateral is a cyclic quadrilateral. Okay, and what they are saying, the opposite angles of a cyclic quadrilateral are supplementary. What is given over here? The given thing is that is ABC that is quadrilateral ABCD is a cyclic quadrilateral, is a cyclic quadrilateral. This is what is given, and what you need to prove is angle BAD plus angle BCD equals 180 degree. This is what you need to prove. Also, you can prove angle ABC plus angle ADC equals 180 degree. You need to prove any one of them because the opposite angles of a cyclic quadrilateral are supplementary. That's what you need to prove. Now, how we can prove this? See how we can prove. If I draw a center to this circle, okay, and if I'm drawing this to radius also, okay. Now I know that angle angle AOC will be equal to twice of angle ADC. Yes or no? Yes or no? How many of you are saying yes? You can raise your hands. Yeah, you can raise your hands or you can nod your face. Okay. Yeah, fine. Because angle at the center is always twice the angle which it will the same arc subtend at the any other point on the circle on the same side. Also, angle AOC, this was this angle. Also, reflex angle AOC. Reflex angle AOC means the angle which is greater than 180 degree. This angle. Reflex angle AOC will also be twice of angle ABC. Yes or no? Again, angle at the center is always twice which it will subtend at the any other point on the circle. Understood? This angle will be twice of this angle. Are you getting it? Yeah. What I know, angle AOC plus reflex of angle AOC will be equal to how much? 360 degree. If I add 1 and 2, if this is 1 and this is 2, adding 1 and 2, adding 1 and 2. So what I get? Angle AOC plus reflex angle AOC will be equal to twice of angle ADC plus twice of angle ABC, right? But the sum of these two angles will be equal to 360 degree, yes or no? If I take 2 in common in both of them, it will be angle ADC plus angle ABC. And if this 2 goes on this side, it will be 180 degree will be equal to angle ADC plus angle ABC. What is ADC and ABC? ABC and ADC. They are the opposite angles of a cyclic quadrilateral, and this is what the proof that if you add two opposite pair of cyclic if you add two opposite angles of a cyclic quadrilateral, what do you get? They are supplementary, that the sum of both of them will be equal to 180 degree. Is this clear to everyone? Yeah, the next theorem is the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Now this is very easy. It does not have nothing, it does not have much thing to prove. Means if I draw any cyclic quadrilateral inside, if I'm drawing this cyclic quadrilateral inside, and if I draw any of the line and extend it for an exterior angle. Now what you need to prove in this is if this is A, B, C and D, what is given in this? The given is quadrilateral ABCD is a cyclic quadrilateral, is a cyclic quadrilateral. Yeah. After this, what I need to prove, what do you need to prove? The exterior angle of a cyclic quadrilateral, that means this exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, that is this angle. What we need to prove? We need to prove is angle DC ABCDE, angle DBCE is equals to angle BAD. That's what you need to prove. Now, it's a very simple proof. We know that angle BCE plus angle BCD equals 180 degree. What would be the reason? Linear pair. Yeah. Also, angle BCD plus angle DAB equals 180 degree. What is the reason? Opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are what? Are supplementary. Yeah, this is the reason. Now, once you know this, what I can say? Angle BCE plus BCD is 180 and angle BCD plus DAB equals 180. So, if this is 1 and if this is 2, equating 1 and 2, so what I get? Equating 1 and 2, what I get? Angle BCE plus angle BCD is equals to angle BCD plus angle DAB. Yeah. So since BCD and BCD are same in both the sides, so you can cancel both of them. So therefore, angle BCE is equals to angle DAB. Angle BCE is equals to angle DAB. Hence proved. Clear? Okay. Now see to the first question which you have. Now in the given figure, O is the center of the circle and angle AOB, angle OAB and angle OCB, they have given 30 and 40 degree. Find angle AOC. You need to find angle AOC. How you can find angle AOC? See how we can find. It's very easy to find now. If I draw a line over here, if I draw a line over here, what I know, AO equals OB. So triangle AOB is an isosceles triangle. And now once it's an isosceles triangle, so this angle will also be 30 degree. Yes. Similarly, BOC is also an isosceles triangle. So this angle will also be 40 degree. So if this is 30 plus 40, this whole total, since angle ABC equals 70 degree, then angle AOC will be twice of this angle because this angle is at the center. So that will be 140 degree. Clear? You don't have to write it like this. You have to write all the statements. That is, in triangle AOB, AO equals OB. Therefore, triangle AOB is an isosceles triangle. Therefore, angle BAO equals angle ABO. Therefore, angle ABO equals 30 degree. That's how you need to write. Again, in triangle OBC, OC equals OB, and therefore angle OBC equals angle OCB. Why? Because they are isosceles triangle. Therefore, angle ABC equals 70 degree, and therefore angle AOC equals 140 degree. Why? Because the angle at the center subtended by the arc or by the segment will be twice of the angles, will be equal to twice the angle which it will subtend at any other point on the circle on the opposite side. Okay, next. Now in this, in the given figure, angle BAD is 65. Angle BAD, okay, this angle is 65. Angle ABD is 70 degree. This angle is 70 degree. Angle BDC is 45. Okay, this is 45. You have to prove that AC is the diameter of the circle. First, tell me, any one of you, when we can say AC is a diameter?
When any angle subtended from it is 90 degrees.
So, which angle should be 90 degree?
Either ADC or ABC.
Exactly. Either ADC or ABC. If they are 90 degree, then what we can say that AC is a diameter. Okay, then we can say AC is a diameter. Now, how we can find those angles? See, if this is 70, this is 65, this will be how much? Using angle sum property of triangle,
45.
this will be 45. So if this is 45, this is 45, angle ADC is 90. And since angle ADC is 90, therefore AC is the diameter. Understood? You can write the statement, or you want me to write the statement? You can write it, no? I'm explaining you because writing it will take a lot of time. Yeah. After that, you need to find what is angle ACB. How you will find? If anyone can solve, please solve it and tell me what will be angle ACB. And if you are telling the answer, I will be asking all the reasons also. Because some of you may be having a textbook and they will be watching over there and giving the answer. If you're giving the answer, I'll be asking reasons also randomly. So please solve it and give your answer.
Sir, it is angle subtended by the same segment.
Exactly. So what it
So
is?
ADB is equal to 40.
Yes, exactly. So
ACB
that
is also.
this angle and this angle, as you can see, these two angles, that is ADB and ACB, are subtended by the same arc or same segment, you can say. Therefore, these two angles will be equal. So therefore, this angle will also be 45 degree. Understood, everyone? How many of you have understood? Now, the next. The next is this third question. Calculate the value of angle OCA. Okay, this question I'll write it properly how you can have to write it exactly in your exam. Okay, now what they have given O is the center of the circle and angle AOB is 70 degrees. Calculate the value of angle OCA. 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 This angle you need to find. Okay, what do we know? Angle OCA will be half of angle AOB. Why? Angle at the center is double the angle subtended at any point, at any point on the circle by the same arc. Yeah, angle at the center is double, so this will be half. Angle OCA will be half, so that is half of AC AOB, that is 70, so this will be 35 degrees. So you got this angle is 35. Next, what is angle OAC? OAC. Now in triangle AOB, in triangle AOC, OA is equals to OC. Therefore, triangle AOC is an isosceles triangle, right? Therefore, angle OCA is equals to angle OAC. Therefore, angle OAC equals the same as what it is OCA, that is 35 degree. Understood? This is the way you should write in your exam, right? But it takes a lot of time to explain with this. That's why I directly explain on the diagram only. Understood how to write? So for the further problems, I will not be writing all this thing. The only thing is you need to understand the concept. So I'll be explaining, we'll be doing interaction while how we can solve that problem. Okay? So this is also 35 degree. Next problem. Now you need to find the values of A, B, and C. How you can find? See, B will be half of 30, 130, yes or no? Because angle at the arc and angle at the center. So that will be 65 degrees. And we know that angle A plus angle B should be equal to 180. Because opposite angles of a cyclic quadrilateral are supplementary, right? Therefore, if I put 65 over here, A plus 65 equals 180, then A equals 180 minus 65. So 180 minus 60 is 120, then 65 is 1115. So we got the value of A as well as B. Understood this, the first one? Yeah. Can you tell what will be angle C? Any one of you? Yeah, it is Isha, Pritika, Navya. Your answer is right. See over here, some of you might have considered that this quadrilateral is also a cyclic quadrilateral. That's why you are saying this as some of you have said that it is 68 degrees, right? By saying that the sum of these two angle is 180 degree. It's not. Why? Because it's not a cyclic quadrilateral. See, this vertex is not touching the circle. That's why it is not a cyclic quadrilateral. Okay? Yeah. So what we can do is we can make one line over here. Now this will be a cyclic quadrilateral. If this is 112, this angle will be half of this, which the where this will be now 56. Yes or no? Yeah. If this is 56, then this will be, it's a cyclic quadrilateral now. So this will be 124. Understood? Clear? Yeah? Okay. Fine. Next. Now these are the questions for the question number 5. So as you can see, all of them. We'll try to find in all of them the values of A, B, C, and D. Okay? Yeah. Can you solve what will be angle A? Please try and give me your answer. What will be angle A? See over here, I'll explain. See, this is 70, this is 35. That's what you have. If DB is a diameter, what do we know? That this hole will be 90 degree. This DAB will be 90 degree. So this angle will be 20 degree. Yes or no? We know that. Now, if this is 35 and this is whole 90, so in triangle ABD, by using sum of interior angles of a triangle, then this angle will be how much? See, 90 plus 35 will be 90 plus 35 is 125. So the remaining angle is 125. So for 55. And this angle will be equal to this angle. Why? Because they both are inscribed in the same segment. They are in the same segment, no? So angle A will also be 55. Understood, everyone? How many of you have understood? You can raise your hand, you can nod your face, anything is fine. Okay, got it. Next, please try to solve what is angle B. Yep. Now see over here, I'll solve this question. How we can solve the question number B first. See, this is 120. What we can do, this is angle 25. Okay, this AB is not even a diameter. So what we can do, mm, yeah, what I can say, this angle will be 60 degree because it's a linear pair. If this is 60 and this is 25, 60 plus 25 is 85. Yeah. So this angle will be how much? 95. This angle will be 95. And angle ACB will be equal to angle ADB. Why? Because they both are in the same arc. So therefore angle B will be 95. Understood? The next, try to find what is the value of C. Yeah, Shruti. Can you give me the reason, Shruti? How did you get?
Yes, so because AB is the diameter, then APB will be 90 degree. Then if we see in triangle APB, angle PAB will be 45, 90 plus 45, and we will subtract that from 180. We'll
Okay,
get 45.
okay,
Then PAB and PCB are subtended from the same segment. So
okay, okay.
PCB, that is D, is also
Yeah,
45.
yeah, perfect. Very good. That is D is 45. I hope everyone has understood this. Yeah. Now see to the sixth problem. What they have given in the figure, AB is a common chord. This AB is a common chord of the two circle, and if AC and AD are diameters, prove that DBC are in a straight line, and O1 and O2 are the center of the two circles. Fine. what they have given, O1 and O2 are the center of the circles. You need to prove that DBC are what in the same line. How we can prove? See, this is also very easy actually. We know that angle ABC will be equal to 90 degree. Yes or no? Why? Because AC is a diameter. Yeah. Also, angle ABD is also 90 degree. Why? Because AD is a diameter. Yeah. So, angle ABC plus angle ABD equals 180 degree. Therefore, DBC are in same line. Understood? Since the sum of these are linear pair, no, it's forming a linear pair. This plus this are 90 and 90. So it will be 180. So it's a linear pair. So DBC is a straight line. Understood? Clear? Next. In the figure given below, find angle BCD. So almost, this is also almost the same. Uh, you can solve this question in your homework. Will not be solving all of them. Wait. This also you please solve in your homework. Now let's solve this question number 9 right now. Try to find angle CDB and give your answer in the chat box.
Meter. Yes, sir.
Yeah, what will be angle CDB?
Sir, it would be 90 minus 43 degrees, so it would be
Yeah, wait. AB is not a
47
diameter.
degrees.
No, no. AB is not a diameter. It's not given that AB is a diameter.
Okay.
Yeah, so how we can find? Dikshant, can you tell how we can find angle CDB? Pritika,
Sir, it is 49 degrees.
perfect. Isha, that's right. Since CAB and CDB are subtended on the same segment, therefore this angle will be 49. Perfect. This will be 49. Now angle ABC will be what? Again, ADC and ABC are subtended by the same segment. So this angle will also be 43. Okay. After that, what is angle ACB? ACB. How you will find ACB? That's easy. Sum of interior angles of a triangle. If this is 43, this is 49, this will be 180 minus 49 minus 43. Whatever the answer comes, that will be your angle ACB. Understood? Yep. Now let's solve question number 11. What they have given. In the following figure, O is a center of the circle and triangle ABC is an equilateral triangle. You have to find angle ADB and AEB. Daksh, yes. What will be angle AEB? Yeah, angle ADB will be 60 degree. Why? Because if this is 60 degree, if this is 60 degree, this will also be 60 degree. Angle subtended by the same segment. Yeah. And now what will be angle AEB? Opposite pair of a cyclic quadrilateral. Therefore, it will be 120 degrees. Yeah. Clear, no? Next. Yeah. Please try to solve question number 13 by yourself. Fine. See over here, as you can see that this is 130. So this will be how much? Since it's a cyclic quadrilateral, so this will be how much? 50. And since AB is a diameter, then this will be 90. Yeah. Now, if this is 90, then what will be this angle? This will be 40. Yeah. Angle sum property of triangles. Yeah. By using angle sum property of triangles, we can say that this angle will be 40 degrees. Yeah. Now we'll move to the next.
Sir, angle AOB would be equal to angle OCB
Wait,
and
wait, wait, wait. Angle AOB will be equal to angle
OCB.
OCB. No, because
No,
this
okay, sir.
angle
I
is
got
at the
it.
center. Okay, so this angle will be half of this angle. So this angle will be 30 degree. Got it? Yeah. Next. Then you can use in triangle DCB, you can use angle sum property of triangle to get angle. What is angle DBC? That's what
Can
your
you
angle
explain again?
OBC. Yes, Dikshan.
How the 30 came?
Okay. See, AOB, as you can see, this is the angle subtended by this arc at the center, and this angle is on the point on the circle, which is subtended by the same arc. As we know, that angle subtended at the center will be double the angle subtended which it will subtend at any other point on the circle. Yes or no? So that's why this can be 30. Yes or no? Understood?
Yes. Yes.
Okay, that's it. Then by using angle sum property, you can find what is angle OBC. Clear? Please try solving this. You have to find what is angle DCE and what is angle ABC. It is given that O, whenever they give you a point and O is given, that means you can consider that it is a center of the circle. But instead of O, if they are giving this as P, so do not consider that as a center of the circle. Only if the letter is written as O, only then it is a circle. Only then it is a center of the circle. Or else they have to mention it that the point P is a center. Otherwise, we cannot consider. DCE will be 50. Why? Because see, we know that it will be a right angle. Why? Because DC is a diameter, so this angle will be 90 and this angle will be how much? 50. Yeah, because angle sum property of triangle, simple. Yeah. Now what will be this angle? See, can you find what is this angle?
30.
Yeah. If this is 100, by using angle sum property in triangle OBC, if this is 50, this is 100, then it is already 150 and this will be 30. Understood, everyone? You can raise your hands if everything is clear to you, or you can also nod your face. Clear? Okay. Now in the given figure, AC is the diameter of a circle whose center is O. Okay, O is the center. A circle is described on AO where AO is a radius for this circle and AO is a diameter for this circle. Okay. See what all things they have given first. Let us discuss them. In the given figure, AC is the diameter. AC is the diameter of the circle whose center is O. A circle is described on AO as diameter and AE a chord. AE is a chord of the larger circle intersects the smaller circle at B. So you need to tell what is proof that AB equals BE. That's what you need to prove. Okay. So how we can prove this? Okay. So what we can do in this figure, if I take this figure over here, if I extend this line over here, not extending, if I draw this line from O to E, this will be an isosceles triangle. Everyone knows about it. Yeah. After this, if I draw a line over here also, see what we need to prove, AB equals BE. Now to prove that AB equals BE, we need to prove that these two triangles are congruent. As you can see also, these two triangles are congruent only. Yeah, but we have to prove it that the two triangles are congruent. Now how we can prove? See, we know that this side is equal to this side in triangle ABO, or you can say AOB, in triangle AOB and triangle EOB. So what all sides you have? AO is equals to OE. Yes or no? Why? Because radius of the same circle. Next, which is the other one? This angle will be equal to this angle. Why? By using isosceles triangle property in this triangle, the whole triangle. In triangle AOE, angle BAO is equals to angle BEO. Yes or no? Since they are isosceles triangle due to isosceles triangle property. Now, which is the other angle which is equal? Yeah, OB is equals to OB. Why? Common. They both are common. Fine. Now what we can say that the two triangles are congruent by which test? The two triangles are congruent by which test? Please tell. No one knows. How is it possible?
SAS.
SAS. No, it's not SAS. See, for SAS,
SSA. SSA.
ASS. It is ASS test. Means
Oh,
one
our
angle
teacher
at two
told that it
sides.
is not that way.
Means, see, SAS, it cannot be SAS in any way. Either A should be written first or A should be written late in the last. But it cannot be SAS. Why? Because if it is SAS, the angle should come in between the two sides. We have used this angle. We have used this angle, right? Since we are using this angle, so either this and this, if we have proved that they both are equal, then we can say it is an SAS. Otherwise, we cannot say. So it will be an ASS or SSA test, whichever you can write AAS by ASS test of congruency. Yeah. Now, if the two triangles are congruent, then AB equals BE by cyclicity. Therefore, AB equals BE by cyclicity. Is that clear? Yeah. Now, as you can see, the parallelogram inscribed in a circle is a rectangle. That's what you need to prove. A parallelogram inscribed in a circle is a rectangle. Now, how you can prove it? See, whatever they are asking that it is a rectangle, so draw a rectangle only. Okay, and consider it as a parallelogram. Because a parallelogram cannot be inscribed in a circle. Are you getting it? So that's why if any parallelogram is there, yeah, let's consider that ABCD is a parallelogram. Yeah. Now, how we can prove that it is a rectangle? So what is the difference between a parallelogram and a rectangle? Rectangle, all angles are equal. Okay, that is also fine. All angles are equal and all angles are 90 degree also. Yeah, all internal angles are 90 degree. Also in rectangle, the diagonals are bisecting even in parallelogram, it's bisecting. Yeah. Now consider its ABCD is a parallelogram. So since ABCD is over here, what they have given? Quadrilateral ABCD is a parallelogram. Okay, quadrilateral ABCD is a parallelogram. Inscribed in a circle. Now you have to prove that it's a rectangle. What do we know? AB is parallel to DC and AD is parallel to BC. Also, we know that AB is equal to DC and AD is equals to BC. This all things we know. If it is a parallelogram, all this thing will be there. But we need to prove that angle ADC is a 90 degree. So if we prove that, then it will be a rectangle. Right? So how we can prove? A parallelogram inscribed in a circle is a rectangle. Yeah. If I draw diagonals to this parallelogram, okay, what I don't know whether it's a center or not. I don't know this center will be the center of the circle, yes or no, I don't know about it. Okay, so how I can say that it will be a rectangle only? Yeah, I know that it's a cyclic quadrilateral, yes or no? I know that it's a cyclic quadrilateral. That is angle BAD plus angle DCB equals what? 180 degree. Angle BAD plus angle DCB equals 180 degree because it's a cyclic quadrilateral. Yeah, but what we know, opposite angles of a parallelogram are equal. Yes or no? Opposite angles of a parallelogram are also equal, no? So angle BAD, I can write again angle BAD equals 180. So twice of angle BAD equals 180. And then what I can say? Angle BAD equals 90 degree. Understood? If in a parallelogram, if any one angle is 90 degree, all of them have to be 90 degree. Yeah. If in a parallelogram, any any one internal angle, any one internal angle is 90 degree, then it's a rectangle. Then it's what? It's a rectangle. Clear? Yeah. Is this clear to everyone? Yeah. Okay. Now the next. The rhombus inscribed in a circle is a square. It's a similar sum. You can solve this in your homework. Okay. Please solve this question in your homework. Then wait. In the given figure, AB equals AC, prove that DECB is an isosceles trapezium. It's simple. Two circles intersect at P and Q through P and enter P. The figure given below shows a circle with center. Yeah, let's solve question number 23. What will be the relationship between angle A and B? Can you derive? You have to find what will be the relationship between A and B. Yeah, it's easy, it's not difficult. See, if I draw a line over here, if I draw a line over here, this angle will be half A. What I get? Half A plus B. Half A plus B will be equal to how much? Will be equal to how much? 180 degree. So if I take 2 in the LCM, A plus 2B equals 180 degree. So A plus 2B equals 360 degree. Got it? Wait. A plus 2B equals 360. No. Half A plus B, A plus 2B. Half of A plus B equals 180. 2 in the LCM. A plus 2B upon 2 equals 180. Then A plus 2B equals 360. Yeah, that's right. A plus 2B equals 360. Got it? Is this clear? Next, find the measure of angle OAB. OAB if OABC is a parallelogram. Okay, OABC is a parallelogram. So if OABC is a parallelogram, then A will be equal to B. Yes or no? So A plus 2A will be equal to 360. So 3A will be equal to 360. And then A will be equal to 120. Yes or no? Angle OAB, AOB. You have to find what? OAB. OAB. Oh, you have to find this angle. Okay, if this is 120, then angle OAB will be 60 degree. Yes or no? This angle will be 60 degree because if these two lines will be parallel, then these two will be co-interior angles. If this is 120, then this has to be 60. Are you getting it? Yes or no? If you are not getting it, then please ask, I'll explain. It's a cyclic quadrilateral. So half A plus B will be equal to how much? 180 degree. Is this right? Up to here, everything is clear. Yeah. So if I take 2 in the LCM, then A plus 2B will be equal to 180. Yeah. Then A plus 2B will be equal to 360. Understood this now, Shruti? Yeah. Now once if A plus 2B is 360 and they have given Find the measure of angle OAB. OAB if OABC is a parallelogram. See, if OABC is a parallelogram, then opposite angles will be equal, no? That will, that is A will be equal to B. So I can write A plus 2A will be equal to 360. So 3A will be equal to 360. So A will be equal to 120. Are you getting it? The angle A will be equal to 120 degree. Yeah? Maybe somewhere the answer is given as the angle A is 60 degree, but that is wrong. That's not right. Are you getting it? Some in some of the books they have given that angle A is that's why you're referring over there. Maybe that you're asking that. Fine. So angle A is 120 degree, and then angle B will be obviously will be same. B will also be 120 degree. Got it? And angle OAB will be 60 degree. Got it? Because of co-interior angles. Fine.